Okay, ji. Assalamualaikum everyone. Let's begin. Today's paper is again an S2 exam. This is November 25 and this is the version 6.5. Let's solve. The first one says the student notes the length T minutes of a certain lecture. Of certain lectures, the results for a random sample of 80 lectures are summarized as follows. So calculate a 96% confidence interval for the population mean length of the lectures. Okay, so first I will write down my formula: x bar minus z value into sigma over root n, x bar plus z value into sigma over root n. Okay, what's x bar? X bar is 6430 divided by 80. Okay, I don't know the z value for now. So let's find out. Let's see, where is my formula sheet? I think my formula sheet is missing from here. Let's quickly search up the formula sheet. Okay. Okay, so this is a 96% confidence interval. So I am going to look at 98%. 98 isn't here. I'll have to go inside the table and look for 98%. So 9798 and then I add 2, so 2.054. Okay, 2.054. I think I am doing fine. Yeah, 2.054. Now I don't have the standard deviation either. So I will have to do an unbiased calculation for that. Let's do that on the side. Let's start doing that. So sigma square is then n over n minus 1. So that's 80 over 79. And then the formula 519740 divided by 80 minus the mean square, which is 6430 over 80. Okay, let's calculate that. Okay, so I'm getting in decimals 37.07. Okay, let's use that. 37.073, let's use that. Okay, so 37.073 over root of 80 mu 6430 divided by 80. I think that should be a small number. 80.375 plus 2.054 into 37.073 over root of 80. Okay, so long calculation, I can't help it. That is something that I have to do. Root of this. So 78.97675 and 81.7732. So this one's easy, 81.8. Okay, that one's a little tricky because it rounds off to three significant figures as 79.0. Okay, so that is what I'm going to write my answer as 81.8, correct to three significant figures. Those are the correct answers. Okay, the method used in part is valid because the sample size was large. Explain why the method would not be valid if the sample size were small. The sample size was large, therefore was large and distribution was unknown. Was unknown. So CLT was valid. It would not be valid for small sample sizes. Okay. So that's the reason I think CLT would not apply. That's the answer. A researcher is investigating whether the proportion of families who do not own a car in his town is different from the proportion of the population in the whole country, which is 10.1%. He takes a large random sample of families in his town and finds that the proportion of families who do not own a car. Explain why a two-tailed test is appropriate in this context. Because the researcher wants to test whether the proportion of ownership is different from 10.1%. Okay, state and suitable null and alternate hypothesis for the test. So H naught P equals to 10.1%, H1 P is not equals to 10.1%. Okay. Okay. Then the researcher calculates the value of his test statistic and finds that Z equals to 1.82. He carries out the test at the 5% significance level. So he's taken a large random sample, which means that he should be using a normal distribution. He carries out the test at the 5% significance level. State the conclusion of the test, explaining your answer. Okay, so his Z statistic is 1.82. If I look at the significance level is 5%, which means that both sides have 2.5%. What is my sample size from, what is my significance level from here? That means 1.96. So 1.96 and minus 1.96, if my Z statistic is 1.82, that means I'm in the acceptance region. Okay, so you write fail to reject H naught or accept H naught. H naught, there is not enough evidence to say that, okay, to say that the proportion of ownership is different from 10.1%. Okay, I think that should be the correct answer for 2C. Fail to reject is not insufficient and the proportion is different from 10.1%. That is fine. Question number 3. A certain website receives an average of mu hits per hour in the past. The value of mu was 14.4. After making some improvements, the owner of the wishes to test whether the value has increased. Okay, so mu was 14.4. Mu is now, he wants to test if whether the value of mu has increased. So more than 14.4. So he chooses a 10-minute period at a random and finds that there are 6 hits during the period. You may assume that the number of website receives in any given period follows a Poisson distribution. So lambda is 14.4 for 1 hour. Okay. For 10 minutes is going to be 14.4 divided by 60 multiplied by 10 for 10 minutes. Okay, I don't know the number. I'm going to calculate that. My test statistic is 6. So I'm going to calculate probability of x greater than or equals to 6. Now, greater than or equals to 6 means 6, 7, 8, 9 up till infinity. So I'm going to subtract 1 minus probability of 0, 1, 2, 3, 4, 5. Okay, what is my lambda? Let's calculate that. So 14.4 divided by 60 multiplied by 10. I'm getting 2.4. The lambda is 2.4. So I will have to write all of that. I cannot get away with writing all of that. So please make sure that you remember how you're writing it. Okay, and write it cleanly as well. I'm writing a little dirty, but okay, where's Poisson? Variable, accumulate up till 5 and 2.4. Execute. So I'm getting 1 minus 0.9643. So that's 0.0357. Okay, 3.57, 0.0357 is less than significance level. I think the significance level, no, it's more than significance level. That's 2.5%. So more than significance level. So fail to reject H naught. There is not enough evidence to say that mu is greater than 14.4. Okay, explain whether it is possible that a type 1 error or type 2 error may have been made. Type 2 error because we have failed to reject H naught. Okay. Uh, okay, this is strange. This marking scheme is also asking me whether it is possible or both may have been made. Okay, so I have to justify the both part as well. Type 1 error cannot be made when H naught is not rejected. So unusual. I've never seen that happen on the marking scheme ever, but this one is asking you to do that. Okay, quickly on to question number 4 now. A sports fan produces a magazine each month. All of the starting questions are about sampling, estimation, and hypothesis testing. That's strange for a paper. Okay, but in any case, a sports fan produces a magazine each month on average 1 in 40, 540. So this looks like a binomial to go with. Okay, it says use an approximating convert distribution to find the probability that in a magazine containing 2430 characters, there are at least 4 incorrect characters. So probability of x greater than or equals to 4. What is my lambda going to be? My lambda is going to be 1 over 540 into 2430. Lambda p is small and n is large. It's not asking me to justify, so I'm not justifying it. So that gives me 4.5. So 1 minus probability of 0, 1, 2, and 3. Okay, I encourage that you solve using your calculator as well, ताकि if you've made some mistake while typing it or writing it, you avoid those mistakes during the exam. So 0.658, I think, should be the final answer. Let me check. Yes, that is the correct final answer. Okay, justify your approximating distribution. P is small, but I'm also going to state how small it is. It's less than 10%. Okay, and N is large. 2430 is greater than 50. NP is also less than 5. So it's NP 1 over, so 4.5 is less than 5. So I've justified why I'm not using a normal distribution. I've also justified why I am using a Poisson distribution. On average, you have to do that whenever it's a justification question. Uh, there's no going back on that. Justification means that you have to justify why you're not using the other thing as well. On average, the number of copies of sold per magazine is 123.4 per month. State one condition for X to have a Poisson distribution. So copies are sold randomly and independently and singly. Okay, the other condition could have been that the mean is constant, but they've already stated that the mean is this. So I'm not giving that condition. You're not given that X as a Poisson distribution. Using find the probability that in a randomly chosen one, more than 130 copies. So my lambda is very large, 123.4. So I'm going to use a normal distribution for this. I'm going to say that it's a normal distribution. First, I'm going to do a continuity correction. Point 0.6391. One minus 0.6391. Okay, I'll have to do 0.639 because Z is correct to 3 decimal places, 639. Seven three eight seven and 7386. 7386. Final answer should be 0.261. Let's move on to question number 5. The masses in kgs of large and small bags of tomatoes have the distribution this. And this respectively, find probability of L greater than S plus 0.5. So what I'm going to do is I'm going to move S to this side and say that I now have a difference which is L minus S. So difference then has a normal distribution. This is linear combinations, by the way. So 2.1 minus 1.51 comma 0.12 plus 0.09. So difference is greater than 0.5. 0.59, 0.21. So z greater than 0.5 minus 0.59 over root of 0.21. Okay, so I do normal distribution in my own way. If you have a different way of doing it, please go ahead and do that. 0.57535753 plus 24. 5777. So point. Okay, that should be the correct answer. Let's check quickly. Yeah, that is the correct answer. The price of tomatoes is 4.3. A large bag of tomatoes and a small bag of tomatoes are chosen at random. Find the probability that the total price. So total price is then in the two bags is less than 16. Okay, so how many kgs do I have in total? It says a large bag and a small bag. So what is the mean total? It's going to be 2.1 plus 1.51. So I'm going to multiply 4 4 into 2.1 plus 1.51. Okay, so that's going to give me the price, the mean price. $15.64. Total price variance is going to be 4 square into the sum of the two variances, which are 0.12 and 0.09. So 0.12 plus 0.09 to 16. So I get 3.36. What do I want the total price to be is less than $16. Okay, I think I have made an error. I haven't done 4.3. 4.3. I make these silly mistakes. Two point two four two. 5956. 5956. Okay, then we move on to question 6 quickly. Yeah, that's the last question on the exam actually. Okay, the diagram shows this. If the graph is a straight line from A and B, where elsewhere f of x equals to 0, find an expression for B in terms of A. So half base into height should give me 1. So B in terms of A should be 2 over A. Okay. Given that expected value of x is 4 over 9, find the value of A. So for expected value of x, I want to do x f of x, but unfortunately I don't have x f of x, but I have these coordinates. I can say 0 comma A and this is then 0, 2 over a comma 0. So can I find out the gradient first? So y2 minus y1 over x2 minus x1. Okay, so a over minus 2 over a, so that gives you minus a squared over 2. And the y-intercept is a. So the function is going to be f of x equals to mx, mx plus c, which is also a. So x into minus a square x over 2 plus a. And I'm going to integrate over the entire range 0 to b, which means 0 to 2 over a. Okay, given that, find the value of a. So this is given as 4 over 9. So minus a square x square over 2 plus ax. I've just multiplied, I haven't integrated so far. So a square x cube over 6 plus ax square over 2. And the limits are 0 to over a. Okay, so minus a square 2 over a cubed into 1 over 6 plus a 2 over a squared into 1 over 2. And the other terms are 0 and 0 because x is 0, 4 over 9. So minus a square over 8a cubed into 1 over 6. I hope I'm doing that correctly. I just want to verify if there's something wrong. I think so far it's fine. So x square over 2 and then this. Okay, so far so good. 4 over 9. Oh, I've run out of space as well. I usually run out of space on these expectation parts because you end up using 2 lines instead of 1. So you should be careful as well. So minus 8 over 6a plus 2 over a equals to 4 over 9. So that's 6a minus 8 plus 12 equals to 4 over 9. Yep, that is the correct answer. Okay, using this value of a found in part B, find the value of k such that probability of x less than k is 3 over 4. So I have the function. I can just write out the function, which is 1.5 squared divided by 2. Let's write that in decimals only. So that's easier to write. 1.125 from 0 to k minus 1.125 x plus 1.5. Okay, so minus 1.125 k square over 2 plus 1.5 k minus 0 plus 0.75. 1.125 k square. So this is turned into a quadratic equation. And again, I think that's an easy solution then. You do the quadratic formula. So minus b plus minus b squared minus 4ac over 2a. 2 and 2 over 3. Okay, so I have to decide, find the value of k. So it's either 2 or 2 over 3. I will have to check whether it can be 2. So I'll have to check what the limit for b is. 2 divided by 1.5. So b is 1.33. So k can't be bigger than b. So k has to be 2. So this, sorry, k has to be 2 over 3. This has to be discarded because this is greater than the value for b that I have. Let's check if that is the correct answer. Okay. Uh, k over 2. It says with explanation. So you also have to tell me why you've discarded it. That's strange. Okay. But you have to tell me that b is 4 over 3. So discarded. Okay. That's it for this exam. Thank you for watching.